Hi guys, so today we're going to look at operations with functions, and we're going to look at some basic operations, and we're also going to look at compositions. So to start, what's really important here to understand is just our notation. Okay, these problems are not going to be difficult to solve, but the notation sometimes can be difficult to understand. So we want to make sure we understand what these questions are asking us to do. So f of x plus g of x are two separate functions. So if I want to add those two functions together, you may see that notation look something like this. All right, same thing down here at the bottom. If f minus g of x means I'm taking the f of x function and I'm subtracting the g of x function. Same thing with multiplication and division. Again, that notation means take your f of x function and multiply it by the g of x function. And same thing with division, but with division, remember, we cannot divide by 0, so that g of x function just cannot be 0. So let's look at an example here. So I have f plus g of x. So that means f of x plus g of x. So that just means I'm going to take the f of x function and add the g of x function. Combine any like terms you can combine. And that is it. Same thing on b. F minus g of x means f of x minus g of x. All right, so this ends up being 3x minus 2 minus parentheses, because we are subtracting the entire function, x squared minus 5. So this would be a negative x squared plus 3x plus 3. All right, now this also had us to state the domain of each of these. Now, domain, the biggest things you need to remember that are restricted potentially, you cannot divide by 0, and you cannot have a negative under a square root. Okay, as long as those things aren't happening, our domain for the most part is going to be negative infinity to infinity. Okay, so for both of these are just these are quadratic functions. Okay, think about what a quadratic function looks like. Your domain is not restricted. There's every x is possible here. All right, f of x times g of x. Okay, we would actually FOIL this out. So 3x cubed minus 2x squared minus 15x plus 10. And there's no like terms to combine, and that is it. And again, domain here would be from negative infinity to infinity. All right, then let's look at f over g. Okay, so again, I would just write this as 3x minus 2 over x squared minus 5. But when it comes to domain here, remember, you cannot divide by 0. So that means that x squared minus 5 cannot equal 0. That means that x squared cannot equal 5. That means that x cannot equal plus or minus the square root of 5. So if I wrote that in interval notation, negative infinity to negative root 5, union, out of space here, negative root 5 to root 5, union root 5 to infinity. All right, so the hardest operation for us is probably going to be composition. Okay, there's two different notations for composition of functions. The one you'll probably see most often is what looks like this. The way we read this is g of f of x. So g of f of x. Okay. Over here on the left, that is the similar notation. It means the same thing. But that open circle is a composition. Now, if it's a closed circle, it's multiplication, but that open circle is another symbol for composition. Okay, so again, we read this as g of f of x. So let's look at this first one. Okay, this wants me to evaluate f of g of 3. So to evaluate these types of problems, you start with what's most on the inside. Okay, the inside most parentheses is g of 3. So to evaluate g of 3, I would plug in 3 for x into the g function, which gives me the square root of 3. So I replace that with the square root of 3. So now I'm evaluating f of the square root of 3. So in the f of x function, everywhere there's an x, I replace it with the square root of 3. This doesn't simplify anymore, so I would leave it here. All right, look at b, g of f of negative 2. Okay, so f of negative 2 would become 2. because I would take negative 2, plug it into the f of x function. Negative 2 plus 4 is 2. So now I'm evaluating g of 2. Plug in 2 to the g of x function, and I get the square root of 2. All right, if you feel comfortable with this, pause the video and try C and D. All right, so let's see G, okay, or C. I'm going to do G of 9, so plug in 9 to the G of x function. Okay, the square root of 9 is 3. Plug in 3 to the f of x function. 3 plus 4 is 7. G of f of negative 5. Plug in negative 5 for f. That gives me negative 5 plus 4, which is negative 1. Plug in negative 1 to the g function, which is the square root of negative 1. So there's two ways you can write your answer. You could say it just does not exist because there is no real answer, or you could say it was equal to I because we all know what the square root of negative 1 is. But again, this will not have any real solutions to it. All right, where this gets a little bit trickier is when we look at it in terms of a function as opposed to just finding a value. Okay, so g of x, we already know what g of x is. So f of g of x means we're going to take the g of x function and we are going to plug that in everywhere there's an x in the f of x function. So this is going to become f of the square root of 3. Everywhere there's an x in the original function, I plug in the square root of x. So this becomes the square root of x plus 4. All right, then the opposite way, g of f of x. Okay, so g of f means I'm going to plug in the f of x function into the g of x function. So this is going to be g of x plus 4. So everywhere there's an x, I'm replacing it with x plus 4. Okay, and it's important to note that these are different functions. Okay, it does say to write the domain because our domains here are different. The domain for e would be from 0 to infinity because you cannot divide by a negative number or take the square root of a negative number, sorry. Whereas our domain for f is going to be from negative 4 to infinity. All right, so f of x and g of x, f of g of x and g of f of x are not necessarily the same thing. All right, so again, if you feel pretty comfortable, pause the video and try these examples, but I'm going to go ahead and work these ones out for you. So f of g of negative 5, so plug in negative 5 into the g function. So I'm evaluating f of negative 2. So negative 2 squared minus 4. 4 minus 4 is 0. All right, looking at b, g of f of 6. So I'm doing g of, plug in 6 into the f of x function. So 6 squared, 36 minus 4. So g of 32. 32 plus 3 is 35. All right, so f of g of x means that I'm going to evaluate f of x plus 3 because that's the g of x function. So everywhere there's an x in the f of x function, I'm going to replace that with x plus 3. So this is x plus 3 squared minus 4. So x squared plus 6x plus 9 minus 4. So x squared plus 6x plus 5. And then D, same idea, but it's flipped. G of f of x. So g of the f of x function, which is x squared minus 4. So this is going to be x squared minus 4 plus 3, which is x squared minus 1. All right, so now we're going to look at composition and operations just with some different methods. Okay, so now we're going to look at a table of values that's going to do a very similar process. So on A, f plus g of 1, that means that I'm going to do f of 1 plus g of 1. So I look at my little table. Okay, so I'm going to look at f of 1. So when x is 1, okay, then I can see that f would be 3 and g would be 4. So f plus g of 1 is 7. All right, f minus g of 3. So I look at that table. When x is 3, f is 0, g is 6. So this is negative 6. f times g of 2. Okay, so I look at 2. F times g is -6. And now we'll look at composition. Okay, so similar process. So I start with the inside, f of 3. So when x is 3, then f of x is 0. So now I'm evaluating g of 0. So at 0, g is 7. So my final answer here is 7. Okay, f of g of 1, again, that's that other notation, which just means f of g of 1. Okay, g of 1 is 4. So f of 4, when x is 4, f is 2. Okay, f of 1, okay, so when x is 1, f of x is 3. So f of 3, when x is 3, f is 0. All right, then g of 4, okay, so when x is 4, g is 0. So I'm evaluating f of 0. Okay, when x is 0, f is 5. All right, then we'll do g of 4. Okay, so g of 4 is 0. So then I'm evaluating g of 0. When x is 0, g is 7. All right, the last thing we're going to look at, same stuff but on a graph, okay? But again, similar process, start with the inside most for those compositions. Okay, so g of 0 is what we're going to find first. So when x is 0, on the g of x function, my value is 2. So then I'm evaluating f of 2. So on the f of x function, when x is 2, then y is 9. Okay, look at b, f of 0. Okay, so f of 0 means when x equals 0, then y is equal to 1. So g of 1 means when x equals 1, okay, then this graph is at -1. Okay, f of 0. So I do f of 0, which is 1. When x is 1, y is 6. And then f of g of 4. So g of 4, so I look at the g of x function. When x is 4, I get 2. Okay, so the answer to that one's 2. Whoops, try to erase that point. Okay, so f of 2. So when x is 2 on the f of x function, I get 9. And the last two, that's just operations again. F plus g of 3 means f of 3 plus g of 3. So f of 3 means when x equals 3, okay, y equals 10. When g equals 3, y is equal to -1. So 10 plus -1 is 9. And then f times g of 2, again, when x is 2, I get 9. When g is 2, I get -2. So 9 times -2 is -18. All right, and that's it for compositions and operations.